Hello, Santosh here, and today I am going to deliver the lecture number 3, and that is the part 1 on the aggregates. It is the important constituents of any concrete, and it is very important chapter. So I am requesting you to listen this lecture till the end to get the ideas about concrete mixture and concrete technology. So let us start the lecture. First of all, what is the aggregate? The aggregates are defined in IS code 383. The material used for manufacture of mortar and concrete such as sand and gravel etc. are called as aggregate. Aggregate are the materials basically used as a filler with the binding material in the production of mortar and concrete. म्हणजेच काय आहे तर ॲग्रिगेट हे फिलर मटेरियल आहे आणि ते बाइंडिंग मटेरियल बरोबर वापरलं जातं. म्हणजे बाइंडिंग मटेरियल हे सिमेंट आहे आणि कशासाठी वापरलं जातं तर प्रोडक्शन ऑफ मॉर्टर आणि कॉन्क्रीटसाठी वापरलं जातं. म्हणजेच हे मटेरियल काय असतं तर सँड किंवा ग्रॅव्हल असं असू शकतं. दे आर डिराइव्ड फ्रॉम द इग्निशियस सेडिमेंटरी अँड मेटामॉर्फिक टाईप ऑफ रॉक्स ऑर मॅन्युफॅक्चर्ड फ्रॉम द ब्लास्ट फर्नेस स्लॅग. Blast furnace slag म्हणजे काय? The slag which is obtained from the iron industries is termed as a blast furnace slag. Aggregate form the body of concrete and it reduces the shrinkage and affect the economy. What is the shrinkage? That is reduction in volume due to application of load or some external factor. Then we are going to classify the aggregates based on geological origin. First aggregates are the artificial aggregates. These are the broken bricks, blast furnace slag or synthetic aggregate. And artificial aggregates used in foundation work, they are not suitable for RCC work or mass concrete work. Then blast furnace slag has a good fire resistance capacity because it is used in iron industries but responsible to corrosion due to sulfur content. It is used in precast concrete products, means the production of electrical poles, production of pipes etc. Then we are going to discuss the synthetic aggregates. They are produced by the thermal reaction or thermal procedure. It may be an expanded shell or it may be a clay, are used for lightweight concrete, means synthetic aggregates are used for lightweight concrete. And what are the natural aggregates? These are the river sand or a rock. Then a requirement of a good aggregate. This question is all the time asked in examination. The aggregate should be clean, free from organic and inorganic impurities. It should have rough texture for better bonding. If it has a smooth texture, then bonding is not possible. And should be non-reactive type to avoid the alkali aggregate reaction. म्हणजेच ॲग्रिगेट असे पाहिजेत की त्याच्यात अल्कली ॲग्रिगेट रिॲक्शन नाही झाली पाहिजे. should be well graded with minimum voids. What is the well graded? Means combination of all sizes of that particular aggregate is the well graded. And what is the uniformly graded? Uniformly graded means having the same size. So one must know the difference between well graded and uniformly graded. And should have angular shape for strong interlocking. If the aggregates has angular shape, then interlocking of aggregates is possible. Then should be strong, having sufficient impact crushing and abrasion strength. So aggregates should have strong against impact, strong against crushing and strong against abrasion. Then it should not absorb the water more than 5% from added water to avoid the variation in water cement ratio. And good aggregate, it should not be absorbed. Good stone, it should not be absorbed more than 1%. Okay. Then should be durable to resist the atmospheric variation. What is durability? It is the resistance to the weathering action. Then we are going to discuss the properties of fine and coarse aggregate. First of all, source. Almost all aggregate materials originate from the bedrocks. There are three kind of rocks. Everybody knows this type of rocks because we have studied these rocks in geology. First type of rock is igneous, that is Agnijanya. Second is sedimentary, and third is metamorphic, that is Rupantarit. This classification based on the mode of formation of the rocks. The concrete making properties of an aggregate are influenced up to some extent on the strength of parent rocks together with subsequent process of weathering. म्हणजेच इग्निशियस रॉकचे जे ॲग्रिगेट असतात ते स्ट्रॉंग असू शकतात आणि सेडिमेंटरी आणि मॅटामॉर्फिक रॉकपासनं जे ॲग्रिगेट असतात ते तेवढे स्ट्रॉंग असणार नाहीत. द क्वालिटी ऑफ ॲग्रिगेट मे व्हेरी टू ग्रेट एक्सटेंट ड्यू टू चेंज इन द स्ट्रक्चर अँड टेक्स्चर ऑफ द पॅरेंट रॉक फ्रॉम प्लेस टू प्लेस. इट इज quite obvious. Then based on size, under given set of conditions, the larger possible size of aggregate practicable to handle should be used. Means minimum size should not be used, the larger possible size should be used. Thickness of section, spacing of reinforcement, clear cover, mixing, handling and placing techniques limit the maximum size of aggregate that can be used under certain given conditions. For heavily reinforced concrete member, the nominal maximum size of aggregate is restricted to 5 mm, less than the minimum clear distance between the main bars, or 5 mm less than the minimum cover to the reinforcement, whichever is smaller. हे महत्त्वाचं आहे. हेविली रिन्फोर्स कॉन्क्रीट जर असेल तर स्पेसिंग जवळ असतं, त्यामुळे कव्हरच्या स्पेसिंगपेक्षाही छोटा साईज हा त्या ॲग्रिगेटचा पाहिजे. बट from various other practical considerations, aggregate having a maximum size of 20 mm are normally considered satisfactory for RCC work. 10 mm, 20 mm. 20 mm is the maximum size. Aggregates are divided into two categories. First is the coarse aggregate and second is the fine aggregate. And all the time one must know this classification based on the size, because all the time it is essential in concrete technology. And in oral, such a type of questions are always asked. The size of aggregate bigger than 4.75 mm is considered as a coarse aggregate, and aggregate whose size is 4.75 mm or less is considered as a fine aggregate. Coarse aggregate म्हणजे खडी थोडक्यात आणि fine aggregate म्हणजे थोडक्यात sand. Then based on the shapes, classification of aggregate and their particle shape. First is the rounded shape. Rounded means, please see this figure. This is the rounded aggregates. Fully water-worn or completely shaped by attrition. Hence, the 33% to 35% of the voids ratio not suitable for the concrete, because these are the rounded. Example: river or seashore gravel, desert, sea, shore and wind blown sands are the rounded type of aggregates. Then we are going to discuss the irregular or partly rounded. Irregular or partly shaped by attrition and having rounded edges. The voids ratio is 35% to 37%, useful for medium quality concrete, pit sand and gravel, or land or dak flints or cuboid rocks. These are the examples. Then angular aggregates possessing well-defined edges formed at the intersection of roughly planar faces. The void ratio is 38 to 41%, best for the concreting. म्हणजेच काय होतं आहे तर हा voids ratio वाढत जातो आहे. राउंडेडला कमी होता, इरेग्युलर किंवा पार्टली राउंडेडला तो वाढला, अँग्युलरला अजून वाढला. Crushed rocks of all types are termed as are the examples of this angular aggregate. And then flaky aggregate, angular having small thickness as compared to the width or length. It has the highest percentage of voids, suitable for lower grade of concrete. Laminated rocks are the example of flaky aggregates. Then we are going to discuss the bulk density of aggregate. Bulk density for the coarse aggregate is defined as the ratio of net weight of aggregate to the volume of aggregate. Weight divided by volume is the bulk density. That is density. All must know that, and generally expressed in kg per liter. Sometimes it is expressed in kg per meter cube also. In case of fine aggregate, the density of aggregate is considered along with the volume of voids or empty spaces between the particles is known as a bulk density. म्हणजेच bulk density ला काय कन्सिडर करतात व्हॉल्यूम मध्ये voids सुद्धा कन्सिडर करतात आणि empty spaces सुद्धा कन्सिडर करतात. जनरली डेन्सिटी ऑफ सँड ranges between 17 to 25 kN per meter cube. Various factors affecting the bulk density of coarse aggregate, that is shape. Due to less void, rounded particles have greater bulk density. Greater compaction gives the greater density. It is very simple. When compaction is greater, the voids are less. When voids are less, density is more. Increase in the grading increases the bulk density, and the graded aggregates have less voids. म्हणजेच वेल ग्रेडेड ॲग्रिगेट्स असतील तर voids कमी असतील आणि voids कमी असतील तर डेन्सिटी जास्त असेल. Then we are going to discuss the next property, that is texture. Surface texture is the property which defines whether the particular surface is polished or dull or smooth or rough. That aggregate surface, it may be polished or dull, it may be smooth or rough. Surface texture depend on the hardness of the rock, grain size also, pore structures also, structure of rock also, and degree to which the forces acting on the particle surface have smoothened or roughened it. As the surface smoothness increases, we know that contact area decreases. Then durability. What is the durability? It is resistance to the weathering action. Some of the aggregates contain the reactive silica which reacts with the alkalis present in the cement, hence reduce the durability. That is, alkali aggregate reaction is dependent upon the following factors: reactive type of aggregate, high alkali content in the cement, availability of moisture, and optimum temperature condition. Alkali aggregate reaction can be controlled and durability can be increased by following methods: selection of non-reactive type of aggregates and by use of low alkali cement. It is very simple. Then we are going to discuss the impurities in the aggregate. Aggregates that contain the excessive amount of tannic acid, vegetable matter, oil, humid acid, sulfates, free carbonic acid, alkali, salt, etc. are considered to be harmful. The presence of such a harmful substances prevents the proper adhesion of cement on the surface of the aggregate and thus affects the properties of concrete adversely. Then we are going to classify the various impurities in the fine aggregate. First is the organic impurities and second is the inorganic impurities. What are the organic impurities? These impurities contains the decayed vegetable matter, organic clay, decayed animal matter, etc. It affects the setting time and hence affect the strength of concrete. If the organic matter exceeds the limit, then the fine aggregate is either rejected or it is completely washed before using. Inorganic impurities, these are mainly contain silt and clay. Silt and clay are the inorganic, and vegetable matter and other decayed animal matters are the organic impurities. Inorganic impurities such as a clay and silt, if exceed, it can be easily removed by washing the sand. Then we are going to discuss the fineness modulus. All the time examples are asked in the competitive type of examination on fineness modulus. It is a number, it is not, it is a dimensionless quantity, it is a number which gives an idea about the fineness or coarseness of an aggregate. Aggregate किती फाइन है किंवा किती कोर्स है ह्याची आयडिया देतो, और गिव्स अन आयडिया अबाउट द मीन साइज ऑफ पार्टिकल्स इन द एंटायर बॉडी ऑफ द ॲग्रिगेट. म्हणजेच मीन साईजची, ॲग्रिगेटच्या मीन साईजची कल्पना देणारा असा नंबर आहे, त्याला आपण फाइननेस मॉड्युलस म्हणतो. It may be defined as the cumulative percentage of residue retained on each of the 10 Indian standard sieves ranging from 80 mm to 150 micron and dividing the sum by 100. Each succeeding sieve has the half the apparatus size of the previous one. The size of the sieves are 80, half of 80 is the 40, half of 40 mm is the 20, half of 20 mm is the 10, then 10 half is the 5 but it is 4.75 mm, then 2.36 mm, then 1.18 mm, then 600 micron, 300 micron and 150 microns. What is the fineness modulus of fine aggregate? It is sum of cumulative percentage of weight retained up to 0.15 mm sieve, means 150 micron sieve divided by 100. It is recommended that fineness modulus of the sand should not be less than 2.5 and should not be more than 3. 2.5 and 3 is the range of fineness modulus of fine aggregate. Fineness modulus of the sand varies. Under fine sand it is 2.20 to 2.60, but we have to restrict it up to 2.5. Then medium sand it is 2.60 to 2.90, it is well within the limit. And for coarse sand it is 2.90 to 3.20, but we have to restrict it up to 3. Then we have to discuss one example, that is calculate fineness modulus, that is Fm for given data of fine aggregate. Total weight of that aggregate is 1000 grams. The size of sieve is 4.75, 2.36, 1.18, 600 micron, 300 micron, 150 micron and pan. And what is the weight retained? That is 20 in grams, 75 gram, 210 gram, 2.274 grams, 305 grams, 106 gram and 10 gram. Then we have to write the sieve size in mm, then weight retained as it is, and then we have to calculate the cumulative weight retained. How it is calculated? For 20 it is 20, but for another 20 plus 75 it is 95. Then 95 plus 210, that is 305. This is the procedure to obtain the cumulative weight. But for pan we have to make it dash. It is not make cumulative weight retained like this. For the pan it should not be considered. And how the percentage cumulative weight retained is calculated? For for 20 grams we have to calculate the percentage for 1000 gram, that is 2%. For 95 grams we have to consider the percentage for 1000 grams, that is 9.5. Accordingly, percentage cumulative weight retained is calculated, and we have to make the summation of that percentage cumulative weight retained, and we get it divided by 100 like this. 287.3 divided by 100, we get the fineness modulus of that particular fine aggregates as 2.87. It ranges between 2.5 to 3, so it is a good one. Okay, one must remember this example. We have to calculate the cumulative weight retained. How we calculate the cumulative weight, I explained here. How we calculate the percentage cumulative weight retained, that is for 1000 gram, that is 100%. So for 20 grams it is 2%. Accordingly, we have to calculate the percentage cumulative weight retained. We have to make summation of a percentage cumulative weight retained and divide it by 100. We get the fineness modulus. So simple. All the time such examples are asked in diploma and degree level type of examinations, and also in competitive type of examinations. So it is enough for this lecture. So you must listen my lectures till the end, and for more details and notes you may please contact my administrator. His number is 87668470055 and he is Mr. Viresh, and my email ID is svkulkarni72@gmail.com. So please listen my next lecture also. Till then, bye bye, see you.